Good afternoon, everyone. Today we welcome Charles Parker, who's going to talk about chemical production at Flixborough.
Good afternoon, everybody. I worked at Nypro for about 7 years in the 1970s, and today I want to look at the history of the site, the reasons why it is where it is, and also talk about both the fertiliser factory and the Narren plant. Now, I want to say before I start that I'm not a chemical engineer, so I'm not an expert in the processes that we're going to talk about. Okay, so going back into history, in the 18th century and up to the 18th century, farmers were forced to use natural fertilisers such as animal manure, guano, and blood, fish and bone, etc. But with the advent of the Industrial Revolution, there was a demand for more efficient fertilisers and more consistent fertilisers, so that they knew that they could put on a certain weight per acre and be guaranteed some reliable results. So early in the 19th century, we started to get ammonium sulfate produced as a byproduct from town gas production. And at the same time, or slightly later, they started to get sodium nitrate imports from Peru. So this played an important part in agricultural developments in the 19th century. In 1843, Edward Packard developed calcium superphosphate by dissolving animal bones in sulfuric acid, and he opened the first dedicated fertiliser factory built near Ipswich in the 1850s. Now, after the First World War, ICI developed synthetic production of sulphate of ammonia. There's been huge demand for fertiliser during the First World War, and agricultural production had been boosted to its absolute highest. So there was a real demand for this. ICI had been heavily involved in armaments production during the war, and as peace came, it could turn its attention to more peacetime products. And with the development of sulphate of ammonia, we could use this as a fertiliser for alkaline soils, because the ammonia ion which was released, that formed a small amount of acid which lowered the pH balance of the soil, and it gave essential nitrogen for plant growth. The only problem with the use of ammonium is that it's got a relatively low nitrogen content. So compared with ammonium nitrate, you need considerably more ammonium sulfate, which means you've got increased transport costs. Now, also during the 1920s, there was an agricultural depression. There was a glut of cheap imports and cheap imports of superphosphate, and this led to rationalisation and modernisation of the fertiliser industry. The photo which was shown here shows that at that time they were using a lot of chemical guano, which was a synthesis of the same product that was used in seabird droppings. So these have been imported, and there was overproduction, and the fertiliser industry really started to struggle around about 1930. In 1929, Edward Packard, who developed the original fertiliser process, he merged with Joseph Bison and Prentice Brothers, and they formed Bison, Packard and Prentice. And over the next few years, this conglomerate bought out 32 of the existing small fertiliser producers. These were mainly small family-owned companies, and on the back of that, They then formed 5 new ventures, which allowed them to really streamline the market and make it much more efficient. One of the products of this development was they decided to build a new fertiliser plant in Lincolnshire. And in 1937, Bison, Packard and Prentice and West Norfolk farmers set up nitrogen fertilisers to build a plant to manufacture ammonium sulphate to use coal gas from Normanby Park Steelworks. And this work started in Flixborough in March 1938 on a site down by the river. We have to take a step backwards and have a look why the Bison, Packard and Prentice decided to come to Lincolnshire. Normanby Park Steelworks, which was built in 1912, was north of Scunthorpe. The other major steelworks were all to the south and to the east, but this was a brand new plant on a clear site, and it was next to the ironstone mines. So it was able to process the local iron ore fairly cheaply. In addition to opening the fertiliser plant, they also opened Flixborough Wharf at the same time. The reason for this was that it was cheaper to send steel to South Wales by sea than it was to send it by rail. We've also got to look at the North Lindsey Light Railway, which played a key part in all of these developments. The North Lindsey Light Railway was built between 1906 and 1911 to service these ironstone mines to the north of Scunthorpe. It was also the connection for the Normanby Park Steelworks, and in 1938 it was extended to service both the wharf and the fertiliser plant. So here we say, here we see the first sod cutting ceremony for the North Lindsey Light Railway in 1906. And this is Sir Barclay Sheffield with the spade cutting the ceremonial first sod, and the Sheffield family in Normanby Park were one of the major sponsors of the railway. This is the original site, and it was originally planned to run from Scunthorpe up to 2 sites on the bank of the River Humber, at Wintringham here and Witton here. The reason for this was there was a wharf at Wintringham, and they planned to export iron ore and coal from that wharf. And there was also a ferry terminal at Witton, and there were regular ferries on the Humber at that time, which serviced these villages here, and also came down and stopped at Burton, Stather, Gunness, and right down to Gainsborough. So this was all part of the scheme to fit in with this. This is Normanby Park Steelworks. The railway that we are talking about runs somewhere across here to the north. You can just see it on that picture there. It runs across here. The actual access to the North Lindsey Light Railway comes across here and goes across Normanby Road, which is this road here. So this is Scunthorpe down here. This is Normanby Road, which runs past these steelworks down towards the Flixborough Junction, Normanby Park, and on to Burton Stather. This is Coningsby Village here. Okay. So this was the extension. The original railway ran up to Dragonby sidings, just here, the exchange sidings, and it was in 1912, it was extended to service Normanby Park Steelworks here, and then in 1938, it ran down the hill, and there were 2 connections, one to the wharf and one to the fertiliser factory, which is shown on here as chemical works. This is Flixborough Wharf, characterised by these 2 huge gantry cranes, which loaded the railway wagon, loaded and unloaded unloaded the railway wagons which ran on these sidings here. These are the settling ponds for the wastewater from the steelworks, and this is where the railway connection comes in. And originally, you can just see there's a redundant branch there which ran into the fertiliser plant. So this is the nitrogen fertiliser plant as originally built. So this was built between 1938 and 1941. It's in 3 sections basically. This is the ammonia reform plant, which is where the coke gas came in, and it was compressed and then separated out into pure ammonia. We've got a couple of ammonia spheres here. You can see that one there. There's also a smaller ammonia sphere here. This is the oleum plant, which is where the sulfuric acid was produced, and this was then fed into this plant here, where the ammonia was bubbled through the oleum, and that produced the sulfate of ammonia fertiliser, which was stored in these 2 stores here. These stores are made of concrete. Ammonium sulfate is a very aggressive product, and it attacks most metals. So the stores, they are precast concrete, and they are fed by a conveyor along the top. That line there, you can see it is conveyor for the dried sulfate of ammonia. So production started in March 1941, but the plant was bombed by the Germans 2 months later. 5 workers were killed, and the ammonia plant was badly damaged. But they soon got it repaired, and it went back into production in October 1941. The plant was progressively improved, and by December 1962, the cumulative output was 1 million tonnes of ammonium sulfate. So the process was, first of all, we'll look at the ammonia. So the coke oven gas came from the steelworks. It was fed through the gas reform plant, where it was compressed and went through a series of strippers and separators to bring out the pure ammonia gas. Sulfur, in the form of spent oxide, which I'll talk about in a minute, was converted into fuming sulfuric acid, or oleum, in the oleum plant. That's a very, very high concentration of sulfuric acid. The 2 were then formed together. The ammonia was bubbled through the sulfuric acid. It was then dried, and that was what produced the sulfate of ammonia crystal. And here we can see the first bag of Nitroflix, as it was called, ammonium sulfate, being produced by the plant in 1941. So the gas reform plant, this is one of the compressors which was in there, which compressed the coke oven gas, very rich gas, a large number of chemical products inside it, and it had to be compressed and then went through a series of separators. You can just see the reform plant at the back of this picture on one of the ammonia spheres, and that is the sulfate of ammonia store and the sulfate of ammonia plant there. This is Bison's office as it was when the plant was originally built, and you can see the top of the other ammonium sulfate store just there. And this is inside the control room, and this is a group of visitors being shown around and having the system explained to them. Oleum is basically derived from spent oxide. And what spent oxide is, it was a purifier for town gas. So in the town gas plants, the coal gas was filtered through a series of filters, and that gave a coating. These were sawdust shavings, and the gas was put through there to remove the impurities. And one of the major constituents of those impurities was sulfur, and that is what was put through this roaster, which is a rotary oven, and that roaster produced at the end the fuming sulfuric acid. This is the sulfate of ammonia itself. As I said earlier, this is precast concrete, this building. It is designed to have a similar profile to the slump of the pile of the sulfate of ammonia, and this is the dried sulfate of ammonia coming through on those conveyors that I pointed out earlier. As I said, you can't use most of the conventional methods like steel or aluminium or anything like that inside this building because the ammonia just simply corrodes it. So moving on, after the Second World War, the plant continued to produce fertiliser up until the 1960s. And in the 1960s, Dutch State Mines, which is the Netherlands equivalent of the National Coal Board, Dutch State Mines were looking for a UK plant to produce caprolactam. And what caprolactam is, it's the raw material for nylon 6. It's the organic monomer. And nylon 6 produces long chains of molecules. So unlike a polymer, which produces meshes of molecules, this produces long chains. So it's very suitable for things like ropes and also things like parachute cords and that sort of thing, where you want linear strength. So in 1964, Nypro UK was formed, and this was a joint venture between Dutch State Mines and Thyssen's. Production commenced in 1967, and the target capacity was 20,000 tonnes per annum. This was to be sold to two plants, Courtaulds and British England, and they had plants in Derby and in Northern Ireland, and they were mainstays of the nylon industry in the UK in the 1960s and 1970s. However, Thyssen's didn't really feel that they wanted to continue to be involved in this, and in 1971, their shareholding was bought by National Coal Board Coal Products Division. Now, the Coal Products Division took the byproducts from coke production once again, and they separated these out, and they were used in various chemical industries. So NCB Coal Products took over Thyssen's shareholding, and in 1972, it was decided to extend the plant to produce 70,000 tonnes per annum at a cost of £15 million. So this is the process. So cyclohexanone, hydrogen, ammonia, and oleum. I'm sorry about that. So cyclohexanone, which is a complex hydrocarbon, hydrogen, ammonia, and the oleum, they all became the feedstocks for the nylon production. So the fertiliser plant supplied ammonia, hydrogen gas, sulfur dioxide, and oleum to the caprolactam plant, but the main feedstock was phenol, which was converted to cyclohexanone. And in the 1970s, as coke oven gas was progressively phased out, the North Sea gas came along, then they replaced the coal gas with natural gas. So this is the plant as it was in about 1973 when production was complete. So looking over here, first of all, we've still got the original fertilizer plant as I've described earlier. So those are the two. Those are the two fertilizers stored. That's the aeolian plant. That's the gas reform plant, and that's the railway line into the wharf. This is the caprolactam plant. That was the office block. This was the contractor's office block. This was a store for flaked caprolactam because a small quantity was flaked and put into bags. These are the services and the storage area. So these tanks here, they are storage for caprolactam. That one's still under construction. As you can see, it's going to be covered with another layer of steel or aluminium, and that will be lagged to keep it warm. This is the services area. That's the boiler house. That's the workshop. And this is the effluent treatment plant. That's the railway line coming down from Normandy Park. Now, as is very well known, unfortunately, on the 1st of June 1974, there was a massive explosion which completely destroyed the plant. I don't want to say a lot about this because it's already been well covered in the press and elsewhere. I think most people are familiar with the issues involved, but simply to say that it was caused by the removal of a faulty reactor on section 26, which was somewhere in this area here. Sorry, somewhere in this area here. So that faulty reactor was removed. It was found that it had got cracking, which was caused by temperature variations up and down. It had started to crack, and in order to continue to use the process, a pipe was put in to get from that reactor there, that large pipe there, to that reactor there, that large pipe there. And this is what came out of the inquiry. Because the two reactors weren't perfectly in line, they had to step the pipe. So it had a couple of welds in the middle there. So these are the reactor ends, a couple of welds in the middle there. And because of the heat and temperature changes, that pipe flex. It was supported by scaffolding. Unfortunately, the scaffolding wasn't sufficiently robust to continue to support it as it moved, and it failed at this point here and eventually at this weld here. So after the disaster, they found the pipe, and this was the cause of the problem, which released a large amount of gas. It was at quite a high temperature, it was under pressure, and it was highly inflammable. So as soon as it found a source of fire, unfortunately, a large explosion was caused. Large number of fire engines and emergency crews from all over the East Midlands and South Yorkshire were called up to fight the fire, fight the explosion, and help with the rescue and recovery. And I've just put this one in, and this is the fire engine from Winston, which is about 5 miles from Flixborough, and I knew quite a few of the firemen who were listed here. I used to play dominoes with some of them in the 1960s, and they afterwards they told us, you know, it was quite a harrowing tale that some of them had to tell. and as you can see, they were called out at 5 minutes to 5 in the afternoon, and they were still on duty at 10:30 the following morning. So they were on duty every bit of the night, about 16 to 20 hours. Okay, there was an inquiry in September 1974. Both DSM and the National Coal Board were keen to reopen the plant. They first of all, the British nylon industry still wanted the products from that plant. They were an essential part of their supply chain, and they also felt that they had a duty to the workers who continued to support them. Everybody wanted the plant to be reopened. Obviously, there was some local opposition that felt it was dangerous to rebuild the plant. But in the end, permission was given. Initially, they rebuilt the fertiliser plant, which was the non-contentious part of this, and the second application for the new caprolactam plant, a different plant, only delivering 65,000 tonnes per annum. That was approved in 1976, and over the next 4 years, the plant was rebuilt, and I was part of the team that was involved in rebuilding the plant. So the new plant was really state of the art. So first of all, the sulfate ammonia plant was rebuilt, and they went back to the original production process initially. And this is the new sulfate ammonia store, considerably larger than the previous one. That is aluminium cladding, which has been specially treated. The frame of the store was wood. So there are huge wood frames inside that store and joined together at the top and then cross-braced all in wood. And it was brought in from the continent, and they used foreign erectors to build it, and some of the erection techniques that they used did not get past the health and safety inspector today. So that was an early start. And then after that, we rebuilt the caprolactam plant over the next 5 years, and this shows one of the sections being completely rebuilt. Clearing the site has been a major job in itself, but the caprolactam end was cleared after they started work on the sulfate ammonia plant. And this is how the site was laid out following the disaster. So, first of all, the same basic pipe bridge arrangement and feed that was maintained. The caprolactam sections are there. Okay, the intermediate storage is there. The services and the effluent is over here near to the railway line. This is the fertiliser plant. So that's that huge fertiliser store that I showed you earlier. The offices and the bulk storage were all moved a long way away from the plant. So that's the intermediate storage for caprolactam and the fuel oils and that sort of thing. And that was the bulk storage for the site. That's the laboratory. That's the main offices. That's the gatehouse and the weighbridge. So as you can see, the site is much wider spread out than it was in that original picture that I showed you of the early caprolactam plant. These are the workshops, engineering stores, and all that sort of thing. So everything was dispersed as far away from as possible from the caprolactam plant itself. So if there were any leaks, they could be contained much more easily. So this is the new laboratory. That's the new office block, both under construction. You can see the River Trent in the background. And this is inside the control room of the caprolactam plant. So very much state of the art for the late 1970s. All the absolute up-to-date equipment. And that is the actual caprolactam plant itself. Again, the laboratories, we had specialists involved in the design of the laboratory, and again, they were really state of the art, and the lab technicians were very happy with the new laboratories because they got much better equipment than they've had in the past. The transport links were still maintained for the new plant. So first of all, there was a rail link. These are ammonia containers. So these wagons each contain 75 tons of ammonia, and they were brought up and down the line by locos like this. This is a class 20. It's actually parked upon the wharf. I couldn't find one photo of one actually on the site itself, but there's one of those very distinctive gantry cranes that I talked about earlier. This is one of the two ammonia spheres. They both survived the blast with very little damage whatsoever, which was because of their shape and also they're fairly robust structures in the first place. Caprolactam went in and out by road. This is what was called an isotainer, and it's just going to go onto the weighbridge, which is just there. That's the gatehouse. So it was going to go onto the weighbridge. This is exactly the same dimensions as a standard road container. Articulated lorry, as you can see, so a semi-trailer, and that is jacketed, so it's insulated and it's steam heated. So when it leaves the plant, it is at a temperature which ensures that it will not have started to solidify by the time that it gets to the customer's factory. The services, again, state-of-the-art services. This is the biological effluent treatment plant, which is next to the railway line. That's the railway line there. And the way that worked was that certain sorts of bugs were put into these settling tanks, and they actually destroyed a lot of the contaminants by biological action, so known as the BET plant or audible plant. It was a large site. There were about 450, 500 people worked on the site, 3-shift working, obviously, for the production process. And it had a very strong sports and social club. And the sports and social club produced this monthly magazine. It wasn't produced by the management, it was produced by the employees themselves, so it wasn't a company mouthpiece. It mainly concentrated on social activities, you know, the football results, the cricket results, etc. Now, just going back to production, there were a lot of issues in the 1970s about world overproduction of textiles. What was happening was that the developing world, they progressively were increasing their cotton textile production, which then came up against our homegrown synthetic production. So there were a series of agreements in the 1970s to try and keep world textile production in balance. Unfortunately, by the time we got to the late 1970s, there was serious overproduction still, and as a result, British industry unfortunately became increasingly uncompetitive. And even though they progressively replaced natural fabrics, British textile production peaked in 1973 and then went into decline. And there was almost complete collapse of the UK textile industry, which led to the closure of the plant in 1981 because both Courtaulds and British England closed their UK factories. And this is the key part of this graph. So as you can see, while manufacturing generally increased, UK textile production suddenly slumped in the late 1970s. So about 1978, as you can see, and by 1981-82, it had really gone down. And that hit the plant just as it opened, unfortunately. So our resident cartoonist, who had a strip in Nypro, he characterised the situation with this Night Trek cartoon. Star Trek was the big thing on the telly in the late 1970s, and he related it to that. And he said that the good ship Nypro is marooned in deep space, and there's an enemy spaceship coming along, and unfortunately it looks like it's the official receiver. However, main space fleet is flying along, so I found the home fleet and told them of our flight. The good news is they're moving at full speed, but the bad news is we don't know whether they're coming towards us or going in the opposite direction. Well, they were coming towards us up to a point insofar as they really supported the plant as it closed, but there was just simply no future for it. And so it had to be closed and dismantled, I'm afraid, and the workers dispersed. One of the outcomes of the Flixborough disaster was that a memorial was placed outside the new office park. When the plant closed, it was moved up the hill to Flixborough Church, but sadly, within about a year of it being moved up there, these are bronze mallards returning to peaceful waters to signify the loss of the workers. But sadly, within about a year of it being moved to Flixborough Church, it was stolen and presumably melted down to scrap. So there is now a new, much more sort of substantial and robust memorial in Flixborough Churchyard. And I've been led to believe that since I took that photo, yet another memorial has been built, but I've not seen it, unfortunately. The railway line continued to run down to the wharf for about another 20 odd years, but I believe it closed around about 2007. This is the last photo that I've managed to find of a train actually operating on the line. As you can see, they've not had the week of a train down there for a few years, so it really is approaching the end of the line, so to speak. And the site is now an industrial estate, so it hasn't gone to waste. All those services, all the roads, all the hard standings that were put in, some of the buildings have been put to good use. So those buildings there are the old engineering workshops and engineering stores around there. That's the old fertilizer store. The office block, that's the main office block, that's the laboratory. I understand that both of those have subsequently been demolished, and the gatehouse, I believe, is now a cafe. That's the old tank farm on the south side, and that's been reused, repurposed. Can you still see the railway line? But I understand that they have now started to lift that as well. So all of the transport off the wharf these days is road transport, and it comes out somewhere there onto Scala Road. Okay. And this gives you an indication of the number and variety of different businesses that there are on the industrial estate today. And so that concludes my talk. So thank you from me, and thank you from him. Thank you.